Session 2016, number 2, exercise number 2, so nature of collision. The aim of this exercise is to determine the nature of collision between two objects. For this aim, you have the object A, which is considered as a particle of mass ma is equal to 2 kg and can slide on a friction or without friction. This means that the mechanical energy is conserved, and on a plane, vertical plane formed of two parts which are dn and nm. A is released without initial velocity, so this means Vd is equal to 0, and you have the height d, which is equal to 0.45. And here they are saying that this will be the reference, so the horizontal is passing through Mn. Now the first question is calculate the mechanical energy of the system at the point D. So we'll begin with this part. The system here used is the A and Earth. So in this case, mechanical energy at the point D is equal to the kinetic energy at the point D plus gravitational potential energy at D. So it's equal to half mvd square, and since it's beginning without speed, then this will be equal to 0, plus mgzd. It's above the reference, then it's positive, so it will be equal to mg height at the point D, which will be equals to, we have the mass is equals to, here it's 2 kilogram times 10 times the height, which is equals to, given 0.45, so it will be 0.45, and the answer will be equals to 9 joules. Now question 2, deduce the speed v1a of A when it reaches the point N. Now we know that in order to find the speed, we'll think about the kinetic energy, but since the kinetic energy is not given, then we'll think about the law. And here there's no friction. This means I will use the conservation of mechanical energy. Mechanical energy. And then here the question is, this means ME at the point D is equals to ME at the point N. And ME at the point D is equals to 9. So here it's KE at the point N plus MGZ at the point N. But we know that here at the point N there's no height. This means this is equals to 0 since the height equals to 0. Then it will be equal to half mv square at the point N, and this is 9. The question is to find the speed here. Then in order to find the speed implies, so here it's named v1a, so we'll name it v1. Then in this case we'll have it's equals to v1a equals to v1a is equals to 3 meters per second. This is for number 2. Number 3, A reaches N and moves along Mn with the same velocity, v1a equal v1ai. This means when the object reaches here, then it's continue with the same speed, such that v1a is equal 3 meters per second. Now another object B considered as particle, such that we have mb is equal to 4 kg, moves along the horizontal path m towards N. With the velocity we have v1b is equal to minus 1i. Why is minus 1i? Since it's moving in this direction, which is opposite to the I vector. Part A, determine the linear momentum P of the system A and B. So here, the system is A, B, and the question is to determine P of the system, and this is before the collision. So this means it's equals to PA plus PB. Then it will be M1 V1A vector plus M2 V2A vector. Now Lynch diagonal vector, here if we notice the question is to find PS vector and not PS value. And then here we continue, so it will be equals to 2 times 3i since it's moving with the same direction, plus for the second particle the mass is 4, and the speed, so this is p, and the speed is minus 1i. So the answer will become equals to 2i. Now, question part B. In the part B, deduce the velocity v of the center of mass of the system. We know that P of the system is equal to P of the center of mass. This means this 2i here is equals to m total times vg. So 2i is equals to ma plus mb times vg, and the question is to find v of the center of mass. This means Vg is equals to 2 over the total mass, So it's 2 over 6i, then it's 1 over 3i, which will be equal 0.33i. Now, part 4, after collision, A rebounds and attains a maximum height. So we have a collision now here. This means you must know that we have conservation of linear momentum. This means P after is equals to P before the collision. Now, it attains a maximum height, so here we have a maximum height at the point C. When we say maximum height at the point C, this means V at the point C is equals to 0. And determine the mechanical energy of the system A Earth at the point C. So this is part 4A. The system is A and Earth. So the mechanical energy of the system is equal at the point C is equals to KE at the point C plus PEG at the point C. But since we said there's no speed, since the highest point, VC equals to 0, so we still have mg z of the point C. And C is above the reference, so it's plus, then it will be equal mg plus the height C. And here the answer will be equal to 2 times 10 times 0.27, which will be equals to 5.4 joules. Part B, deduce the speed v2a of A just after collision. Now we know that when this particle came here and collide with B, then it moves here and then reach the point C, which is the maximum height. The question is to find v2a after collision. But we know that along all the track, there's no friction. So this means just after the collision, we have, if this is the position 2 after collision, and this is the maximum point, so we know that ME at this point, this means after the collision, so ME is equal to ME at the point C. And ME here just after will become half mv2a squared. So this is for the after collision. Plus mgz, and we know that there's no, so here we are talking about the mass ma. Okay, so it's the mass ma. And here also it's the mass ma. So, and since there's no height, then this will be is equals to 0, since z equals to 0. Equals to ME at the point C, and ME at the point C would just find it, so it's equal to 5.4. Now the question is to find V2A here, V2A squared, this is 2 over 2, the mass is equal to 2, is equal to 5.4. This means V2A is equal to radical 5.4, which is equals to 2.323 meter per second. This means just after the collision here, the speed v2a is equal to 2.323 meter per second. Now, determine by applying the principle of the conservation of linear momentum of the system AB, the velocity v2b of B just after collision. So here in the part 5, here we have to say that the system is A and B together and apply the law of conservation of P. This means that P before the collision is equals to P after. Now before, what did we have? Before we had P of the system, which is A and B, and we already find it, which is equals to 2i. So this means 2i is equals to P2a, this means after the collision, plus P2b, which is equals here to MA V2A plus MB V2B vector. This is 2i, and we have implies here MA V2A is equals to, we have 2i equal 2 times. Now this is V2A, we found it in the part B, but it's opposite to the x-axis, so I put it 3, 2, 3i. If I want to leave it in terms of vector, or I can say that it's collinear, and then I can find the algebraic value. So, and then here plus, we have to find the second mass is equals to 4, and V2B. The question is to find V2B, So by doing the calculation, we'll have that V2B vector is equals to 1.66 I. So this will be V2B vector. Now the last part, specify the nature of collision. Now in order to specify the nature of collision, what should we do? We should find KE before and KE after. So in order to find, this is 6, KE before the collision is equals to KE1A plus KE1B equal half M1 V1A square plus half MB V1B square. And by putting the numbers, since we have all the numbers, so we'll have here it's equals to 11 joules. And in the second one, KE after is equals to KE2A plus KE2B, which is also equal half MA V2A square. We have V2A 2.32 plus half MB V2B square, which is equal, now we found it's equal to 1.66. So the answer here also will become approximately equals to 11 joules. And since we have the same value, KE before is equal to KE after, then we can say that the nature of this collision is elastic. So we have an elastic collision.